Hey, hi, hello. This is Sandoval, and today I'm gonna be showing you how to uh, go around this tutorial of a simulation model. So the first thing that we need to consider is, basically this exercise is divided in pretty much two main parts. The first part will be about building a model and running it. And then the second part will be about developing an alternative scenario, and then also seeing what are some of the results of the model. Something that you find important here, or that we need um, to consider for this exercise, is that okay, you need to have already installed the software WIP, and you also need to already have download some of the files that are available in the that I send you as an attachment. So these are the three files that you need to have for this exercise. Now, in this case, what we're going to build is a very simple system that we have discussed. So basically, it's going to be a system that is where the water sources, or the sources of water, are a river, then you have an aquifer, and then we're going to have three different water demands: rural, agriculture, the city of Watsonville. In time, the city of Watsonville will have demand called wastewater treatment plant, WTP of Watsonville, called WTP Watsonville, and then this will discharge to the river. So let's start by creating a new area. So you need to go to so now for this part you will need to go here to area, create an area, and then here it will ask you the name. So in this case you're going to call it exercise, let's say 5. It's going to be an initial folder that is initially blank, and it will have no protection here. So after this, it will come this this window, and basically what you need to say is what are the boundaries of the WIP area. So something that you should do when you're here is try to, you can see that in this area I'm just clicking, doing the left click and then trying to select an area close to the Monterey Bay where our project is located. Our project is located here. So once you have somehow this a little bit more visible, then you can just go and draw a rectangle here. And once you have it drawn, and you can draw many of them just by clicking and then dragging. But in this case, our area of interest is here. So we're just going to be doing, actually, it's a little bit smaller. So this is our area that we'll be working on. Then you click OK. And now we are here. This is our boundaries. So we're now just here. Now the other thing that we're going to do right now is to set the general parameters. So you will have to go to General, Years and Time Steps, and this window will appear. You will have to say here that the current year it will be 1999, and that the last year of running it will be 2013. Okay. The steps will be 12 steps per year, meaning 1 per month. Based on a calendar, we're going to start our simulation in January. And you just need to click close. We're going to be building the water sources. Not building, we're going to be defining, drawing our water sources. The other part that I want to show, or that I want to explain here, is that this is kind of the main page, the main interface of WIP. WIP has basically this, which is the schematic, and then there are other, this is the schematic, then there are other tables that are, well, other windows that you can access in WIP, which is data, and then if you hit results, it will run something, and in this case we don't have anything declared, so it doesn't have to run anything. And this is how to set up some specific outputs. But let's go here to schematic. The first thing that we're going to do is to define this river. So basically what you need to do is to go to WIP, click on top of the river, and then drag it to a particular place over here in the map. And then you can be doing many clicks here until it reaches the bay. Then at the end, double click, and this this dialog box will come. So the name of the river, we're going to call it Pájaro River. And then we're just gonna see finish. Now you can notice here that actually the size of the label is very large. So something that you can do is here, just right click on top of any of each or of any of these, and then go to label size. And in this case, once you have done that, if you decrease this, you're gonna see that the label size decrease or the label size increase. Also, if you right click here, you can actually move the label. So you can put this label here and say, okay, this is Pájaro River. Okay, as I mentioned, this, for now you need to have these three files. So you're gonna copy these files and paste it in the following folder, which is documents, or your documents. And then inside documents, there should be, now that you're installing WIP, there should be a folder called WIP areas. And in this folder, there should be a file in this called ex_5 or exercise number 5. So you can see that it is here. So once you open it, you will have to paste all those files here. Okay, so once you have done that and the files are pasted here, let's take a look at the file called riverheadflows.csv. So here in the file called riverheadflows, if you open this file, what you're gonna find is that it has a series of inflows to the Pájaro River. The units are cubic meters per second since January 1999 all the way down to December 23rd. So we're going to use some data from this first column and declare it in WIP. Make sure that you close this this file before you declare it on WIP. So now, going back to WIP, what we're going to do is locate your cursor on top of the river and then right click. Here go to edit data and then select head flow. Here in head flow, what you're going to be seeing is that this is, now you are in the data window, and what you're going to do is here in head flow, you are going to click here and go to the expression builder. Once you are here in the expression builder, what you're going to do is you're going to declare that the file is read from the file that we just opened. So you just need to move here where it says read from file and double click on it. So this command is going to be here. Now you will have to declare, in this case, if you remember, the name of the file is river head flows. And WIP, what it does is reads the first column as the year, the second column as the month, and it WIP automatically recognizes this. And then it will read as the first column the next one to the right. So in this case, we're gonna declare in WIP that it will read this file. So you need to type here the name of the file, which is river head flows. Here, river underscore head flows, head flow without the S. And the extension is .tsv, comma separate value, and then you will tell them to read it from the first column. So you just click 1. Then you click verify, and it says expression verified. Okay. This will not appear if you haven't copied whatever files you have into this folder. So just make sure to do that. Then you click OK and then finish. Now notice that now you have some values here that now here in this river head flow, you can see now that WIP is reading values from that first column of the CSV file. Now let's declare the let's go back to a schematic, and now let's declare the groundwater, the aquifer. So here, go to this part, which is the element window. Again, click on groundwater, and then drag it and release the mouse somewhere around here. Dialog window will come, and here you just write the name Pájaro Valley Aquifer. So that's the name how we're gonna call this aquifer. So now here is the name, and just right click to move label, and you're gonna see that you can move the label. Actually, here in general info, if you click here a semicolon, now here in the schematic, if you click here a semicolon, aquifer will appear in the following line. So look, now it's Pájaro Valley Aquifer in the following line. Anyway, so you just move here the name, the label. Once again, right click and go to edit data, and we're going to natural recharge. This file, we're going to declare the recharge from here, from aquifer recharge. And again, you're going to see that in this file, we're going to let WIP know that we want to read the files from this first column here. Okay. So here we go again to notice that also in this one in aquifer, notice that the units are million cubic meters. So you just have to be aware that these units in which one you are uploading your data coincide with the units that are used in the software. So okay, so let's go here, let's go to the expression builder, and then once you are in the expression builder, you will do the same. We're gonna say back again, read from file, and here the name of the file is aquifer underscore recharge. So here we type aquifer underscore recharge .csv, and then we're going to tell it to read it from the first column. You click verify, okay, finish, and now the WIP is reading the aquifer recharge. One thing to notice is why there is no aquifer recharge in the months of April, May, June, July, August, September. Basically, what is happening is that the recharge coincides with the precipitation in this area. So the precipitation only happens in October, November, December, January. So that's why you have here the recharge and no recharge in these areas. Okay, now here you can see that there is initial storage, and remember, for us to always calculate any specific storage, we need to have what is the initial storage. In this case here, we are going to declare, you can open here the expression builder and type 400 and then again verify and finish, or you can just type directly here 400 and enter, and it will be the same. Okay, so now you will go back here to the schematic and go and say save this model. Okay, now we're going to declare the three water demands that I mentioned before at the beginning of the exercise. So the first one that we're going to declare is the one for agriculture. So you just again click here in demand and then drag it a little bit right and to the bottom of the aquifer. Once this dialog box comes, we are going to name this demand side agriculture, and then a priority here, we're going to set a priority of 2. Finish. So we have this. If you take a look at this one, we also have here what is the water demands. And in this file that is called water demands, this come from all the files that we've been calculating in previous exercises. But you can see that the first 3 columns, I mean, WIP is going to read the first column as the year, and then the following columns refer to the baseline municipal water demand for 1990, 1991, 1992. You know, all those values were calculated. Column number 2 will be rural column number 3. Also notice that every time that you put a semicolon at the beginning, WIP will not read whatever is to the right of the semicolon. WIP will only read when there is no semicolon or a number. These are in units in million cubic meters. So we're going to declare first the first 3 columns. Column number 3 for agriculture, column number 2 for rural, and column number 1 for municipal. So let's close this file. Go back here to WIP, right click, edit data, annual water use. So once we are here, what we are going to do is again, here in this one we're going to type as units million cubic meters, and then here we're going to say open the expression builder, and in this again we're going to use the command called read from file. Here the name of the file is water underscore demands. So here the name is water underscore demands dot CSV, and the column for agriculture, if you remember, is column number 3. Okay, so then again we click verify, okay, finish. So now it's written that. The other part that we're going to declare is the monthly variation. How does it vary? How the water demand vary through time? How we're going to do this? You just go to this tab that is called monthly variation, and here you're going to select monthly time series wizard. Here we're going to declare these values for agriculture. Okay, so in this case we're going to declare this in WIP. So basically the first one, it will be 1.9, 1.9, 1.9. What it means is 1.9% of the total annual demand. For the upcoming 3 months it's going to be 8.8, then 16.2, and then finally for the last one 6.4. You just click finish, And now you can see that you have declared that monthly variation throughout the time. Go back here and click Save. Now for the city of Watsonville, we're going to do something very similar. Go to the schematic view. Here is the element window, and drag this node that is called a demand side node over here. And we're going to call this city of Watsonville. Okay. Priority number 2. Finish. We're gonna move. We can move this one here. Okay. Now, again in here, what we're going to do is going to right-click on it, edit data. We're going to do the same procedure with this and the following water demand. First, we declare the annual water use rate and then the monthly variation. So here, again, here we select million cubic meters, and we know that for the city of Watsonville, the column is column number 1. So you just go here, open the expression builder, and go here to drag, while double clicking read from file. Here you're gonna call the file that is called water demands, water_demands.csv, and then you're gonna call it for column number 1. Then you click verify, okay, finish, and now we have that annual demand declared. Now we're going to declare the monthly variation for this. So again, you go here, monthly variation, and go to the monthly time series wizard. And here we're going to declare in January 6.5% of the total demand until March, then 8.5 for the upcoming 3 months, and then 9.8 for the upcoming months, and finally, actually we have, yeah, and then 8.5 for the last 3 months. You click finish, and now you have the monthly distribution for the city of Watsonville. Notice that this demand increases in winter, now in during summer, the hot months, and then it will decrease during winter and a little bit in spring, and it will reduce in fall. Okay. Now go to this click that is called consumption here, and basically what this does, it says that of all the water that is coming into the system, some of that water will be consumed, and that means that it may be consumed by it will be taken out of the system. How will that happen here? Well, you know, because basically we consider that 44% of the water that is used in the city is used for the for landscaping, and because of that, all that water will go back into the atmosphere. So that's why we are just using as a consumption value 44. Once you have typed here 44, then you click enter, and that value will be uploaded into the model. And finally, go back to a schematic, and here drag this demand side node, and we're gonna call this only rural, and then again demand priority number 2. Finish. Similarly, like as we have done with the previous one, you just right click, go to edit data and annual water use rate, and in this case remember to click here million, and here open the expression builder, and this we're gonna use the same command, read from file. And here, if we remember, rural is number 2, is column number 2. So here we just add water underscore demands .csv and then column number 2. Verify. Okay, finish. And now it's reading that. Again, you will go to this monthly variation, and then in this case, open again the monthly time series wizard, and then you're gonna declare 5.4 for the first 3 months. Then you're going to declare 7.9 for the upcoming 3 months, then 11.3 for the following 3 months, and finally 8.7 for the final 3 months. You just click finish, and that's it. Now go back here to the schematic and notice that now we have a schematic that kind of pretty much looks a little bit similar of this one that we were discussing at the beginning. If you want to do the nodes a little bit larger, what you can do is right click, go here to node size, and you can increase the size of the nodes so they look a little bit more larger as they look here in the figure. It doesn't have to be exactly the same, it depends on you. Okay, now if we go back here, now we're going to link the water sources with the water demands. How we're going to do this? Well, go here to transmission link, click it and drag it on top of the aquifer. Once you are located on top of the aquifer, release the mouse button, and then let's say in this case double click on top of the center of the agricultural water demand. So double click, and this window, a dialog window will come and will say, okay, do you want to link the aquifer, the Pájaro Valley aquifer, to agriculture? And you just say, yeah, finish. You're gonna do the same with, you're gonna again click here on transmission link and then drag it on top of the aquifer and then release it. And again, you're gonna double click on top of the city of Watsonville. And again, linking Pájaro Valley aquifer to the city of Watsonville. Yes, finish. And then you're gonna do the same for the rural water demands. Okay, now once you have done that, we're going to create here first a wastewater treatment plant. So select this wastewater treatment plant, select it, and then drag it over here. So what's going to be the name? We're going to call this WTP Watsonville. Finish. And you can actually move the label. Okay, once you're here, then what we're going to do is to create a return flow. So we're gonna create a return flow from the city to the wastewater treatment plant, and then another one from the wastewater treatment plant to the river. So let's start with the first one. So select return flow, drag it on top of the city of Watsonville, and then release it. Then you go to this WTP Watsonville and double click here. Let's do the same for the city of Watsonville here. Now from the wastewater treatment plant of Watsonville to the river. Okay, so as you can see, now we have saved your model. Now as you can see, this model is actually very similar of the one that we talked at the beginning. Can you see that? The next step is to run the model. Go here and click results. It will ask you, results are out of date. Do you want to calculate it? Say yes. And you can see that now the software has run this, the model. Now let's go here, and in this menu select demand and then reliability. So a table like this will come. Okay, here, well, you can see that the reliability is about 88, 89%, but you're not sure about those values. So you can actually go to the click on the tab of table. You can actually see the values that are there, which are these. I am basically 89% of reliability. What does this mean is that 89% of the time, the water demand for this, the water demand for these three elements was supplied 100%. So let's go back here to the chart, go here to demand, and then go here to supply delivered. So now you can see, now this, what is showing you is the supply delivered throughout every month. So this is one way of seeing it. You can, here you can select, go to this part that is called stacked columns and select stacked, and then here, the annual total. Okay, so once you have select annual total and stack, it's gonna look something like this. Can you see this? Okay, now let's, as you can see, well, here we have all the historical water demand, but from here you can see all the water demand that we have calculated for the future in this baseline scenario. As you can see, there are some years where actually the water supply was very few compared to what we were expected. So in this case, let's uncheck rural and the city of Watsonville and only leave agriculture like this. Okay, so as you can see, agriculture here we have look, this should be somewhere around this area, but the agriculture has a shortage of water supply in these years. If you now select the city of Watsonville and rural and uncomment unchecked agriculture, you can see that this water demand was increasing, but there were years where actually it was not able to supply as much as it was required. So you can actually, let's go here to this. So there is actually a way of actually that we will provide you these results. Go here to supply delivered, demand, and then unmet demand. So now here you can see specifically in which years was able, I mean, there was not enough water in the aquifer to provide to supply this during these years. You can unclick annual, and this is monthly, where those monthly values are happening, or annual, and you can see the total unmet demand for all these years. Now here you can go to this tab that is called table, and you can actually see what are the exact values. When does these demands, unmet demands, happen, like since 2020, and you can get the statistics of this or just hide the statistics. Something that we're going to do here is also go here to this, well, go back to this, to the chart, go here to demand, and then go to, now excuse me, supply and resources, groundwater storage, and then you can see the storage throughout the time. This is calculating the storage. You can see now how the aquifer starts, declining consistently. There is a very wet period here, but once again, declining resumes. So at this point, don't forget here to hit Ctrl S or save it. And what I want is a screenshot of the schematic view of your model. So go here and get a screenshot of your model here. Also, a screenshot of the aquifer storage results. So go to results, and here in, okay. No, here. Here. All years. And then here all months. And then here, you can actually change this to line. So a screenshot of this aquifer. A summary table of the unmet demand. A summary table of the unmet demand of each water demand. So what I want is that when you go here to demand, unmet demand, that you can get a table out of this. Go here and get this data. If you click here, this icon of export table to Excel, it will export the results to Excel. So then make a summary table of when this storage happened and what is the total amount of unmet demand for each of these different users. What do you think is happening with the overdraft of the aquifer? Is the aquifer being emptied, or is it filled with saline water, with salt water? And now that's a question, and then let's think about the hypothetical case where this model no longer represents the condition of the central coast of California. And now this model represents a small aquifer in the Central Valley. In this case, will the overdraft empty the aquifer, or is it going to be replaced by other substance? And take a look at this figure that we've been discussing. So let's go back here and let's define these two scenarios, or explicitly mention these two scenarios. The first thing is that the previous results the results that we have here are based on the consumption, considering the same trains over the baseline. Remember that simulation models answer the what-if questions. In this case, we are interested in how will the water source, in this case the aquifer, will react if the water demand is reduced in the future. So we're going to declare two different scenarios. The first one is the baseline with the current water trends, and the second one is a scenario called conservation with policies that reduce the future water demand. Now go here to the schematic view, click in area, and then manage scenarios, and this dialog window will come. Here, select this reference scenario, and then click rename. And you're going to rename it as baseline. Okay. Now here, once you have this in baseline, go here, here, and type a description of this scenario. And basically what you can say, okay, this scenario considers the current trend in future and future water demands. Okay. Now let's create another scenario here. Select again current accounts, and then once you have selected current accounts, click on add. And this, we're gonna save this scenario conservation. Okay. Now here in conservation, what you're going to select here, you're gonna say, okay, this scenario considers the future reduction of water demand due to the implementation of water conservation policies for urban, rural, and agriculture demands. Okay, close this and now go here and add save. Okay, now let's modify the water demand for these scenarios. Go here, let's start with the first one that we declare, agriculture. So go here in agriculture, right click, go to edit demand, annual water use rate. Okay, now sometimes when you're here it will appear that you're in this current account. Now click on this drop menu and select conservation. Once you're here in this conservation, and notice that every time that you're doing something in a scenario, the scenario will appear here on red. Now you can select here demand sites, and you can see that right now in the conservation is reading data from the columns 1, 2, and 3. In fact, we want that this is read from this that this will be read in this case for agriculture, that it will be read from instead of from so right now WIP is reading for agriculture from column number 3, then for the city of Watsonville from column number 1, and from rural from column number 2. In this current, now in the conservation scenario we will change, instead of reading it from 3 to 6, from the city of Watsonville instead of 1, 4, and for rural 2 to 5. So this is how we are going to do this. Remember to close that file. So here we're going to open the expression builder, and instead of letting WIP know that read it from 3, let's just call it from column number 6. Now this one, the city of Watsonville, this is for the city of Watsonville here. Notice that when you change something in the scenario it will turn red, so that's how you know that this is something different from the initial year or the current account year, which is 1999. So anyway, open expression builder, and this one change it, instead of reading for number 4, it will be read from column number, from number 1 now to column number 4. Okay, and finally for rural, instead from column number 2 we want it to be read from column number 5. Okay, finish. Okay, now as you can see, all of these now are red, which it means that they are different from the current accounts. So in the current accounts is read from 1, 2, and 3. In the baseline, because we haven't changed anything, it's still reading from 1, 2, and 3 columns. But if you go to the conservation, now this is start reading it from column 6, 4, and 5. Now the next thing that we have to do, go back to schematic, go to general, years and time steps, and now we're going to be running it from this time from 2010 to 2030. And we want to know, what we want to know here is how will these changes will affect the near future. So let's go back here and click results. Click yes. And now, if you have seen before here, let me rerun it again. You're going to see that it will run first the baseline, and then the second one will be the conservation. So look, now it's running baseline and now conservation. Okay, now go back here again to chart, supply and resources, groundwater storage, and then here select all the scenarios, and here now is running the results for both for the Pájaro River aquifer. So you can see that now in the conservation, actually there is a little bit more of the aquifer storage does not decline as much as in the baseline. Basically, I mean, when conservation starts, it's less water is taken out of the aquifer, and by the end it's almost kind of flattened out. While in this there is a continuous trend downwards. There is a lot of more extraction of water than groundwater recharge. You can actually export this chart by clicking here, this icon. So if you click this one, it will export it to the clipboard, and then you can go in your Word file, Control B, and hit export it. So this is one way of actually exporting your results. Anyway, okay, so also you can go here to tables, and you're gonna see that by the end of the storage in the baseline was 33.6 million cubic meters, while in the other one it was 133. So conservation saved in the long run a lot of water. Okay, so now what you need to do, turn in the aquifer storage results like this. Based on the initial storage, how much water was extracted? What is the total delta storage from here, from the beginning of the simulation till the end? What is the total change in storage from here to here for the baseline, and what is the total change in storage from here to here? You can actually calculate it with these values. So based on the initial storage, how much water was extracted? What is the change in storage? How much of this extraction represents in terms of percentage of the initial storage? So the initial storage is 400. The end of the storage at the end of the time step is this much. What is the total delta storage? And that change in storage, that negative change in storage, how much does it compare to this 400? What is as a percentage of that volume compared to 400? So this is the last part of the exercise. Oh, don't forget to click save. Thank you.